GIE Media's manufacturing group. We highlight some of the latest innovations in manufacturing and design to help you gain insights to the newest products and technologies in the medical, aerospace, defense, and electric vehicle manufacturing industries to keep you ahead of the competition.
Hello and welcome to our latest Manufacturing Lunch and Learn from GIE Media. I'm Jake Kaufman, the managing editor for the manufacturing group of magazines at GIE. Very glad to be joined today by EMUGE-FRANKEN USA and Okuma America as they explore how Okuma's multitasking capabilities combined with EMUGE's innovative tools can optimize the manufacturing of complex turbine components. You'll hear real-world insights on enhancing efficiency, precision, and flexibility in aerospace manufacturing. Today's presenters are Evan Duncanson, a milling application specialist for EMUGE-FRANKEN USA, and Errol Burrell, Okuma America's product specialist for CNC machining centers. Without further ado, Evan and Errol, the floor is yours.
Awesome. Thank you, Jake. If we go to the next slide real quick. We were going over today a part that we made at an event in June at Okuma down in Charlotte. We understand that not everybody could go to that event, scheduling wise and everything like that. So we wanted to show you guys that part today because honestly, it's a pretty cool part. It's got a lot of different things on it. It's got fir tree cutters that we call our pagodi cutters. It's got skiving, and it utilizes the multitasking of the Okuma machine. So it's really, really cool how we can put that all together in one package on one machine in one clamping, really reduce time, setup times, cycle times, everything like that.
Okay, thank you, Evan, and thank you, Jake. Just before we proceed with the presentation or the webinar, I'd like to talk about Okuma's Partners in Technology. Now, what is it? Okuma's Partners in Technology was actually formed in 2007 with a group of about 10 companies. And it used to be known as Partners in Think up until 2007, up until last year, 2023, and we rebranded it from Okuma's Partners in Think to Okuma's Partners in Technology. Now, what's it unique about it? Many builders have partnerships with companies such as Renishaw or Esprit, all these companies. But what makes ours unique, we have a purpose-built building which is dedicated to our partners, and they have access to all our hardware, software, to our machines, to our engineering, to all our departments. And it benefits us in many, many ways where we are right at the cusp of any advancements in technology. It gives our partners the opportunity to test their wares as well. But more importantly, the customers benefit, knowing that they're going to get the best of the best and they're going to be at the cusp of a cutting edge of any developments and any tooling right across the board. Now, as you can see, we have lots of 44, maybe 45 customers right now, and we welcome EMUGE, who've just joined us, I think this year or just early last year. Next slide. And right across the board, if you look at the type of partners who were involved, we got automation. So we got Fanuc and Fastums, coolants and lubricants, people like Blaser, metrology, Marpos. So they all play in the same environment in the same area. They all work together, and it's what I would call it a one-stop shop for customers coming in to look at machines. They can also question a plethora of vendors who provide support for our machine tools. Thank you. Next slide, please. Here's just a picture of the facilities. So to the left, you can see the auditorium. We've seen a lot of our partners utilize that building regularly. We have the partners entrance there to the right-hand side, and then we have the partners building. So they also have cubicles, access to the internet. So it's home from home. Try and keep them comfortable. Okay, the next slide, please. So which machine did we use for this presentation? We actually use the MU6300 VL, which is part of the MUV series. It's, as you can see, the design, it's, well, rather than me talk more, let's just play the video. So this is the new MU6300 VL. Now the L designation actually means it has a lathe functionality. And also we have the Green Smart package as well. So the Green Smart package is a saving energy. So it has a collection of features that saves energy, such as from units like hydraulic systems or hydraulic units. So if any motors are idling, it will cease. It has 5-axis functionality as standard, comes with scales and chill ball screws. As you can see, the C-axis is fairly rapid. It runs up to 800 RPMs. Just move on. And you can see we're doing positional 5-axis here, which is what we call dynamic fixture offset. And it's a very rigid design, so it's fully supported. And then when we go to the next slide after this movie, I'll explain why that's the case. So if you look at the structure of the actual machine, if you look at the yellow bridge, it actually sits on a base, which is hand scraped. And you can see the X-axis, the Y-axis, and the Z-axis are always fully supported no matter what direction that they go in. The Z-axis, we have a travel of 600 millimeters, but in some cases we can actually lift that Z travel. The Z travel stays the same, but we can lift the dead space from the table to the spindle nose. We have a Y-axis travel of over a meter, 1,050 millimeters, or an X travel of 925 millimeters. So this is ideal, this machine, for this particular demo, especially when we're doing the roots in the hub, where you definitely need a lot of rigidity, particularly if you want to maintain a finish. So this machine was ideal. And also we're able to have the A-axis is dual driven by 2 motors, roller cam drives. So it's dual driven as well. Move to the next slide, please. So here's an example of the roller cam gear. So really it's a modern version of a worm gear, to be honest. Now, if you look closely, if you look at the 2 outer rollers on the gear, they're going in opposite directions. So that eliminates backlash and makes it a lot more efficient than the old worm gear style. Next slide, please. So here is the capacity of the machine. We can have a diameter of 800 millimeters, 830 millimeters in diameter by 550 millimeters in height. And the maximum weight will be 600 kilograms. Next slide, please. So this is where we really differentiate from a lot of our competitors. So first click. We have a system called the thermal active stabilizer. Now, what this uses real data using thermal couplings to measure any deformation in the casting. In this case, the casting. Next click, please. Also in the spindle. And what we do, we have thermal couplings strategically placed all around certain points on the machine, and we're constantly monitoring any changes on the machine. And if there's falls out of the parameters, then the next slide, please. We calculate the error, the next one, please. And we compensate for any error in real time. This makes the machine very, very accurate and very stable. Next slide, please. So for the standard table, we'll use, in this case, we use a standard table on this machine. It uses a diameter of 630 millimeters with 6 slots. This is for the normal milling machine. But on the next slide, please. In this case, we use, for the turning option, we use a turning table where it has no slots, it's just tapped holes. Next slide, please. So it's a high-performance machine, easy to use. We use a P500 control, the new P500 control. So with the new design, very aesthetically pleasing, but more importantly, it's very, very ergonomically designed. We've got a thermal concept, the bridge style, which makes it very rigid, and gives you very, very accurate finishes. Equipped fully function for 3+2 or full 5-axis, and also the 5-axis auto tuning, which calibrates the machine if there's any ambient changes or any changes in anything with the machine at all. It actually calibrates the 5-axis kinematic instantly with just a 10-minute cycle, and that's it really. And then also the capacity to actually produce 500 cubes per minute using probably like a 63 millimeter face mill. So the reason why we can do that is because every single axis is fully supported. Okay, next slide. Goes to Evan.
All right, thank you, Errol. Yeah, so now I'm going to talk about the EMUGE-FRANKEN tool. So if we go to the next slide, we're going to start with the skiving tools. So, what is skiving? Skiving is kind of black magic to a lot of people. Honestly, to me, still a little bit too. But skiving is essentially just high-speed rotary broaching, right? So if you think of a broach, it's just kind of pushing the material out of the way. And that's what's happening with a skiving cutter. It's just the table is spinning, the part is spinning, and the tool is spinning at high RPM, like Errol said, up to 800 RPM, right? Excuse me. It's currently the fastest way to make gear teeth. It's a little bit more expensive than other options, but if you got to make a lot of gears, there's nothing better than that. If we go to the next slide, we can see the differences in the different, gear making options. So first of all, we have broaching, right? Broaching is very, very fast once you get it set up, right? But it's very difficult to get it set up. It takes a long time. You need a skilled operator to set it up. You need a different machine, all that kind of stuff. And, broaching machines and broaching operators are kind of going by the wayside. So it's a lot harder to get that kind of technology in your shop. Shaping is kind of skiving without the turning aspect, right? So you're just kind of pushing the tool in and out of the gear at several times. Excuse me. So it's very, very good, but there's some downsides. It's a little bit slower and everything like that, and you don't have that kind of nice shearing action that the skiving tool has. Hobbing is good for external stuff. Obviously, it's very difficult to do internal gearing teeth with a hobbing cutter. But again, you need another machine, you need another operator, you need another setup, right? And that hobbing cutter can be very, very expensive. Same thing with a broach, really, right? So if the operator drops one of those things, what do you do? A disc is essentially just a single row of a hobbing cutter. So obviously it's similar to a hobbing cutter, but a little bit slower, right? But cheaper. An end mill, end mill can actually be a really great option for something that isn't on the OD or the ID of a part. We've done ones that on the face of a part, kind of on the face of the diameter there. And really end milling is the only way you can do that. But obviously it's slow because you're making one tooth at a time. And then skiving is really the only tooling offering that can do all of it extremely fast, right? You can do slanted, helical, tapered teeth, all that kind of stuff with a skiving tool. If we go to the next slide. So there's three different kinds of ways we can build a skiving tool. So you would have a tapered tool or a tapered disc, I call them, right? Where your teeth are actually tapered in a little bit, and that actually gives you kind of your relief. Think of it as your clearance angle on a regular end mill. A cylindrical tool, so instead of that, it's just cylindrical. It's more of a straight wall. Excuse me. And then a tool with a shank, right? So normally we only make tools with a shank up to a few inches, right? Because then the carbide gets very, very expensive. After that, larger than that, we go with the disc style, just to save a little bit of cost, right? And then we can do a separate holder to hold that disc very, very tightly. If we go to the next slide, we can see that a little bit further. So we got a little video here. I'm not going to bore you with the whole thing, but this shows you what EMUGE-FRANKEN can offer for the skiving applications. And it's really interesting because we can offer everything other than your part and obviously the machine. That's where Arrow comes in. But we can offer the holder, the work holding, and the skiving cutter all in one package. So you have one contact person, you have one, delivery time, all that kind of stuff. You don't have to deal with all these different companies. The work holding and the tool holding, if we go with our custom made solution, we can go with these expanding bushings and everything that create a ridiculous amount of accuracy and repeatability. We're talking about, plus or minus 2 microns of repeatability on your part, right? So if you're trying to make a gear and it's really, really tight, that's the way to go. We can make the skiving tools in a huge variety of sizes. I think it's down from 0.4 module all the way up to, I believe it's 10 or 12, something like that. But you can see here, so that the holder's off at an angle that kind of gives us our rake angle or our shear angle. And then the part is spinning and the tool is spinning. And we're just going around at high speeds. But if we slow it down, you can see here, the tool's essentially just broaching those gear teeth. It's just really, really fast and a really efficient way of doing it. Excuse me. In just 1 second, we're going to get to an actual live machine demo of it in this video. There we go. So you can see how fast everything's spinning. Everything's synchronized really nicely. You need that synchronization, just like a tap, right? Your Z-axis and your spindle needs to be synchronized on tapping. Same with skiving, right? And that's really where the Okuma machines shine. That they really have that the skiving package that they have on the machines is really, really nice. Arrow will go over that later. And then you can see all the chips once it's done, right? So all those chips, we can go to the next slide while I'm talking about that. All those chips are, obviously from the machining process, but it's moving so fast, it's like you can't even really see what's going on until the part stops and you got gears. So the current reality of a lot of people's workflow is you're not making the same part every day all day, right? Sometimes you're making part A, sometimes part C, sometimes part B, so on and so forth, right? So you need that easy switchover, and to take a piece of material, put it on a machine, hit the button, walk away, come back a few hours later, and you have a done part that has skiving on it or gear teeth, has root form slots, has all these different features on it on one machine, and one clamping is awesome, right? You don't have to go and take this part, put it on the Okuma, and then put it on this machine, and then put it on this machine, put it on this machine. Then you got all those setup times and everything, right? So consolidates it quite a bit. Next slide, please. All right, so we're going to go over our pagodi cutters now. So we're switching from skiving over to pagodi cutters. If we go to the next slide, this is what really shows the strength of the Okuma machine. Like I was saying, we can do all these different operations on one clamping, on one machine, one program, everything like that. Excuse me. We don't need different operators, different setup times, everything like that. I mean, how many times have you put a part on there, cut a feature, take it off to the CMM, you got to touch it up, you put it back, and then it doesn't line back up, right? We don't have to do that in this scenario. If we go to the next slide, we can see the roughing tool for the pagodi cutters. So normally the conventional way to make slots in a disc like this would be, using just a regular square end mill, opening up that slot a little bit, using a smaller diameter end mill, opening up that slot a little bit more, and then using the form fir tree cutter to open up the slot for then the finishing cutter to go in. Now, I just described 3 tools, right? If we put those 2 roughing cutters into one cutter, that's what pagodi really helps us do. Now we can get this tapered tool that removes a lot more material and a lot more even material for then the rougher form tool to come in and remove all that material. You can see just the two different operations there. So you're saving a tool slot in your tool changer. You're saving a lot of time. You know, you can still blast through this material one shot instead of, you know, two different slots and then going over to the form rougher. Next slide, please. So this tool has our patented multi-cut roughing profile on it. So we call it a wave profile. It's a new version of a corn cob roughing style, essentially. It's got this stabilized, excuse me, this stabilized cutting edge. It actually is what we call a chip former on there that really helps the chip curl and get real tight and then get out of the way, right? We don't have any problems with chip evacuation or anything like that. And then this tool has, you know, irregular spacing or irregular indexing, everything like that, and a coolant holes coming out the flutes and everything too. Next slide, please. So what do I mean by when I say pagodi, right? So this is a standard version of a fir tree cutter, and we can see that big gash. We got one flute and we got the next flute, and there's no material between the two, right? If we look at the core diameter kind of follows the form, but it's way smaller than it really needs to be, because it needs to be small enough to have room for, you know, that smallest cutting diameter. But then the larger cutting diameters, there's no meat behind that cutting tooth to protect it from flexing and give it rigidity and everything like that, right? But this has kind of been the reality since the dawn of time for making these tools, right? Next slide. So if we go to you know, pagodi design, they were thinking, okay, they get the, you know, the mad scientists over in Germany were thinking, okay, how do we get the core diameter to follow that profile of that fir tree cutter, right? And that's what's outlined in this blue color. If we go to the next slide, we can see that kind of built out properly, right? So that's the pagodi. So they actually kind of reinvented how to grind a tool. They actually, you know, do some milling while the carbide's in the green state, and then finish grind it and this and that and everything like that. And they produce a tool that now the core diameter follows the shape of the tool and has a lot of rigidity because of that. You have material right behind your cutting edge where you normally wouldn't. And because we don't have that big flute gash, that grinding wheel coming in and removing all that material, if we go to the next slide, we can see how we can get more flutes on the pagodi design than normal. This tool normally would be maybe 3 flutes, something like that, right? And 1, 2, 3, 4, 5, 6, 7, 8, I think, flutes on this tool. Because we don't have that big flute gash coming in and removing all of that material, we can push the flutes a lot closer together. And in a finishing operation, what do we want? We want more flutes, and ideally we want 2 flutes in the cut at all times, right? Normally you have a flute come in, and before the next one comes in and starts the cut, that previous one's already out of the cut. So you have this on off. That's bad for finish, bad for tool life. You know, especially if we're talking about Inconels and everything like that. This, we can get 2 flutes in the cut, so the tool's always deflected, it's always loaded up, right? And we get a very, very smooth cutting action. We go to the next slide. We can see this is actually on the Okuma. This was the day of the event. So this is the skiving cutter, and you'll see just the spindle and the table kind of whirling up together, right? They have to be synchronized, like I said. That cycle took about 45 seconds to make that entire gear, right, on the inside of that part. So 45 seconds to make a gear. Normally it's, you know, I don't know, 5 minutes, 10 minutes, whatever, plus another setup. And now this is the pagodi coming in. Obviously we're just doing a ghost cut for the camera, but that's actual speed, you know, and that was the rougher. So that's roughing in that shape when there was already that slot made. We go to the next slide. All right, so pagodi is a patented design, actually. So you can see the 3 tools that we used here: the rougher, the pagodi rougher, and then the pagodi finisher. And you can see that that core diameter following that profile of that tool very, very nicely, right? And they call it pagodi because it looks like a pagoda Japanese roof system. And with this package, we achieved a 66% productivity improvement. Next slide, please. And I'll hand it back over to Errol.
Thank you, Evan. That was excellent. So rather than focus on the turning or the milling of the fir tree roots, I'm going to focus on the gear package that we offer on the OSP control. Now, if anyone's been in this industry as long as I have, gears are almost like a dark art. And if you don't believe me, if people of a certain age just get a booklet that says the Mechanical Engineering Handbook, you should all have that. Look how many chapters are devoted just to gears. But that said, we've made this very, very user-friendly on the Okuma gear package. And as you can see here, just on this first one, we can decide what kind of scag we want to do, internal or outer, or even in hobbing. Next slide, please. We can even choose the type of cutter. We just want information about the diameter of the tool, the number of teeth, the helical angle, and the direction of the spiral as well. Next slide, please. We can even adjust the crown of the tooth as well. So we've had customers who've used this and use this for production, and they've come right into spec with a lot of their customers. Now, far be it for me to say how accurate it is when it comes to AGMA, which is the industry spec to measure gears, but we've had some very, very good results. Next slide, please. Also, we have the approach angle. So as you go, we go right through the slides. It's just conversational, GUI. Just go in there, answer the questions, fill in the parameters, and you're ready to go. It's fairly simple. Okay, last slide, please. And that'll be it. That rounds up my portion of this event. And hand you over to Jake or Evan.
Well, thank you, Errol and Evan, for today's presentation. Obviously, lots of information, and with that information, we do have some literature that everyone in the audience can download that should be showing up in your chat box in just a few moments. But we do have a few seconds left for Q&A. So it looks like we do have one from Mike, as he wants to know, they deal with a lot of setup delays when moving between operations. What specific features in Okuma multitasking machines can help shorten the setup time? So obviously that one would be for Errol.
Yeah, well, the fact is, I think the answer is in the question, really. It's the multitasking portion of it. The fact that you can maybe combine the turning and milling in one environment, that really does decrease setup times immeasurably. We found a lot of people moving towards a combination of a mill turn or a turn mill in both aspects, so we can do milling and turning in the one environment. So that definitely decreases setup and cycle times.
Thank you, Errol. And it looks like Eric wants to know, they see premature tool failure when machining nickel-based alloys. What advancements in your cutting tools would improve durability and predictability? So obviously that one would then be directed towards Evan.
Yeah, so unfortunately, I can't tell you most of the secrets, right? But I'll give you a little bit of information. So, we're always trying to improve our tool geometries and everything like that, especially for these difficult to machine materials. So, one big thing is coating technology, right? We're always looking at the forefront of coating technology. Also, the edge prepper, the hone on the tool, right? Getting that hone on that tool be a really nice shape and a consistent size and everything like that really helps with consistent wear instead of premature chipping and propagation of chips and everything like that, along with some secret sauce geometry that I can't divulge to everybody right now.
Awesome. Yeah, some 11 herbs and spices, I bet.
Exactly.
So, with that being said, I thank you, gentlemen, so much for the presentation today with Errol Burrell from Okuma and Evan Duncanson from EMUGE-FRANKEN. If you have any questions left for them, their contact info is on the screen. And also, don't forget to download those pieces of literature in the chat box. But without anything left to say, thank you guys so much for the presentation today, and I appreciate your time.
You can listen to all of our episodes of Manufacturing Matters and Lunch and Learn podcast from the MFG Radio Network on Spotify, Apple Music, and on our websites, todaysmedicaldevelopments.com, aerospacemanufacturinganddesign.com, defenseandmunitions.com, and evdesignandmanufacturing.com.